Hello, ladies and gentlemen. Welcome to another pre-calculus lesson for business with Professor Checo. Today's lesson, moving past Chapter 6, which was an absolute nightmare, into Chapter 7, logic, followed by sets. So let's get this started. All right, we'll go preview. All right, 30 questions. Shouldn't be too bad considering this is probably the first set of logic. So, as always, I'm going to go straight to the textbook and see what we're talking about. All right, so logic. A lot of these are going to be easier to explain with sentences and that kind of stuff. So let's look at the kind of logic reasoning that we use in everyday language. If today is Saturday, then Derek plays soccer. And today is Saturday, which means Derek plays soccer. So this is like kind of like a truth table, right? You're going to be saying, making a claim, and then that. Here's another one. If the sum of the digits of that is divisible by 9, then this is divisible by 9. Then the sum of the digits is divisible by 9. So we're just basically working for it. If P implies Q and P, well, that means that Q. So this is, yeah. A proposition is a statement, not a question or demand or command that is either true or false. There is a prime number between 2312 and 2352. So, we got to went straight into our things. All right, so here's the negation. If P is a proposition, then the proposition not P, or the negation of P, is false if P is true, and true if P is false. Oh man, a lot of true and false, a lot of that. So disjunct. If P and Q are propositions, then proposition P or Q, or disjunct that. If both are true, then the false, and then if both are true. So basically, P or Q. So if P is true, Q is true, well then P or Q is true. If P is true, Q is false, well then it's true. If P is false, Q is false, Q is true, then it's true, and only when both of them are false will it be noted as false. And here's a conjunction where we read this as and. So if P and Q are true, then it's true. If P and Q are false, then it's false. False, 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 false. So you guys can kind of see that. Conditional. So here is if P, then Q. So if P is true, then Q is true. If P is true, then Q is false. If P is false, then T is false. T is true, that's true. And then false, false gives us a true. So let's see. If Paris is in Switzerland, then Queens is in New York. But Paris is not in Switzerland, but Queens still is in New York. All right. Okay, and then it just goes into problems, and here's our definition. Converse and contrapositive. If Q implies P, P implies Q, then Q implies P is the converse. And P implies, it's called the converse of that. Not Q and not P is called the contrapositive. So a lot of definitions. All right, problems. Tautology, contradiction, and contingency. A proposition is a tautology if every column in the table is T, and a contradiction if each entry is false, and a contingency if at least one entry is true and one entry is false. All right, so I'm just gonna go through that. Cool. Logical implications and equivalencies. Logical implication. Consider the rows of the truth table and the compound propositions P and Q. If whenever P is true, Q is also true, we say that it logically implies Q, and write P implies Q. That's called a logical implication. Okay. If the compound propositions P and Q have identical truth tables, we say that P and Q are logically equivalent, and write P is equivalent to Q. The logical equivalence. Okay. De Morgan's law is right there. All right, so let's try to get into the questions because this or that. So list the positive integers that are divisors of 52. I mean, there's really nothing here that you guys need from me. All you gotta do is list everything that goes into that. I don't know, 1, 2, where's that? 1, 2, 26, 52. Does 3 go into that? Yeah, 3 goes into it how many times? 14. Does 4 go into it? Yeah, 4 goes into it. How many times? 13 times? I think that's going to be it. Did I? 1, 2, 1 and 52, 2 and 26, 3 and 14, 4 and 13, 6, 7. The positive integers that the divisors of 52 are. Maybe get rid of 52. One, 2, 4. Why is 3 not 1? Isn't 3 times... Oh, 3 times 14 is 42, not 52. My bad. Alright, but you guys get it, right? You get it. 1, 2, 4. That's pretty straightforward. The positive multiples of 17 that are less than 100. I'm just going to go show completed. You're just going to, 8 that are... You're just multiplying. Alright, that's easy. Express the proposition of not Q in each sentence and determine whether it is true or false, where P and Q are the following proposition. P is prime and 95 is odd. Express not Q is not odd. Yeah, that's it. Determine whether the proposition not Q is true or false. It's false because if it's not odd, then it's even, but 95 is odd. Express the proposition, same converse, P implies Q in an English sentence. 77 is prime, which implies 77 is odd. Express the converse in a sentence. If 77 is not prime, then 77 is not odd. I think that's the converse? No, the converse is... if 77 is odd, then 77 is prime, I think is the converse. Q implies P. That's false because a number that's odd, like 9, is not prime. Express the proposition R implies S in an English sentence and determine whether it is true, false, and whether... Okay, so 2 to the 9th plus 2 to the 8th plus 2 to the 7 is greater than 816. 8 times 10 squared plus 6 times equals 816. If this, then that, right? Cool. Is it true or false? I'm gonna say I'm gonna go true. And S is a false. Oh, this doesn't equal 816. I didn't figure it out. Okay, but you guys get it, right? Moving on. Proposition R. I think this is or, right? I think this one is or. Yeah. The V is or, and then the upside down. This would be true. Express the converse of R implies S. The converse is the opposite. So if this equals, then that. If this, then that. Is it true? Okay, it is true. Describe the proposition as a negation, disjunction, conjunction, or conditional. Determine whether the proposition is true or false. If negative 19 is less than 0, then 19 squared. I think this is a disjunction. I don't think they're connected. No. negate, not a negation, conditional? I don't know. Conditional. Yeah. Definitions and vocab, not my best. Proposition is true or false? False, because that squared is not less than 0. Describe the proposition as a negation, conjunction, true or false. 9 is not prime. Conjunction, I think? No. Conditional? Negation. It's not prime, it's true. 2 is even and 2 is prime. I think that's conditional. Is it going to give me what like the definitions are? Conjunction. Is this true? It is true. All right, let's see. If triangle ABC is a right triangle, then an angle has to measure 90. State the converse. The converse of this is if it has an angle that is 90, then it would be a right triangle. If an angle in triangle ABC has a measure, then it is a right triangle. If then, switch them. And then the contrapositive would be not 90, not right triangle. If the angle in triangle does not have a measure, then it is not a right triangle. That would be the contrapositive. Cool. If x is a quadratic function, then f of x is a function that is neither increasing nor decreasing. State the converse. If x is neither increasing nor decreasing, then just switch them. All right, contrapositive would be not, not. So if it is increasing or decreasing, it is not a quadratic. If it is I gotta negate both of them. If f is not a function that is neither increasing or decreasing, then it's not a quadratic what is the difference between these two? Then f of x is not. I need both not, not. Cool. Alright, if n is an integer that is a multiple of 12, then n is an integer that is a multiple of 6 and a multiple of 2. Select the converse. If n is an integer that is a multiple of 6 and 2, then it is a multiple of 12. The contrapositive, if it is not a multiple of 6 and 2, if it is not a multiple of 6 and 2, then it is not a multiple of 12. Construct the p-value, determine. So not p would be false. I need capital. Let's see. P is true, not p. And then q. Is this and or? Oh my god, I already forgot. I think it's or. I think it's or. I think it's or. So I think this would be true. Oh, did double. Not p is false. Not p is true. And not p is true. This is true. This is true. This is true. I think we got true on all of them. Nope. A proposition and its negation have opposite truth values. Let A and B. Oh, this one. False, false should be false. If they're both false, then it's going to be false. There we go. My bad. Continue. Determine which proposition. There was something here. It said contradiction, contingency. I think it's contingency? Yeah, because it depends on what they give. Construct a two table. So here, not p is false, false, true, true. And not p implies q. Not p, false, false, false. I think true. No, let's double check. that. Not P. Maybe these are all false. If it's true, then it's true. Right? So if it's not true, then it's false. If it's false, maybe this one should be true. This one, false. If it's true, that implies false, and if it's true, that I'm not 100% sure here. So let me see. So I had this one right. That's column. But then why is this? Implies Q. Not P implies Q. It implies it to be true. Let me try that one more time. Let's see if I can get this one. Yeah, I'm not sure. Contradictory? No. So then this one is, so let's see this. A tautology if it's each one is true. Contradictory if each one is false, and a contingency. Oh, so it would have been a contingency. So let's try this again. All right, so then not P is implies false, false, true, true. I don't remember what this one was. False implies true, false implies true, true. Was that it? No, then maybe that one was also F, false. Oh my goodness, which one of these is true, true, implies true, true, true? I don't remember. The only one not... Did they switch it on me? Oh my goodness, they switched it on me. I didn't even notice. All right, one more time. Continue. And then this one would be a contingency. Okay, one more time. Not Q is false, true, false, true. So P implies not Q. Does true imply false? Is true. P implies T would be true. P implies I think these guys are wrong. Maybe. Dang it. Which one of these? This one? I'm not sure. False, false, true, false, true. Oh, it was the first one. I'm moving on. Well, this one obviously is a contingency. All right, let's see. Construct a truth table for the proposition. Determine whether the statement is a contingency. So not P is false, false, true. Q and not P. So let's see. Q. All right, now Q and P. Q and P match. False. False, false is true. True, true is false, and false, false is false. So now if I take this Q, Q and is false, false, true, true. Dang it, how far? I gotta see where I messed up. I'm just gonna get it. Let's see. Alright, so correct answer is FFTT. Oh, I messed up the F or F. Oh, I see that one, because if it's false and false, that implies that it's false. And then false, false. Okay. But then why'd I get this one wrong? Q and not is both true. So if it's this is again a contingency. I think I'm starting to get it. Let me try this again. No, let me go back to that one. Okay, so not Q would be false. Wrong letter. Not true, false, true. Not Q and P would be false. True, true is true. False, false is still false, and false. And then this one would be Q. I think these guys are all false. Let's see. Dang it. Where'd I mess up? The problem is I don't know where I messed up. That's fine. F, T, F, F. True. How? Oh, because it's or. Oh my goodness. Oh, they keep changing the freaking letters on me. And this is a contingency. Dang it. Alright, let me go back to that one. It keeps trying to trick me. So false, true, false, true. Not Q and P. They have to match. So that's false, 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 false. Oh, wait, I did the wrong letter. Not Q and P. False, true, false, false. And then Q or have to be true. So here, Q is true. Here, this one is true. Here, this one is true. And then here, they're both false. All right, I get it. Again, this is a contingency. All right, so P implies Q. Was that 15? Whatever. Maybe it was 9. No, it was 15. So let's see. Not P would be false, false, true, true. And does Q imply, if Q is false, if Q is true, does that imply that I don't know. All right. So this is going to be constructed table. So first, does P imply Q? True, false, false, true. Because if I'm saying it's true, that means it implies true. If it's true, then it's false, it's false. If it's false, then it's true, then it's false. And if it's false, then it's false, then it's true. Now this is and. Q and. So Q would be these guys match. These guys match, but they're false. These guys match, don't match. And then these guys don't match. Oh, I think it's this one has to be true. No, where'd I mess up? Your answer, TF, this one. P implies... Okay, let's try that again. Contingency. Let's try it again. So P implies, so I guess this is just, is Q true? Yes. No. Yes and yes. P and this, yes, no, no, no. Okay. Contingency, check. Construct a two table for the following proposition. If P, then Q. If P implies Q, that's true, that's false, that's true, that's, if that's false, then that's false. I think that's true. Not P would be false, false, true, true, and then P implies Q. So now let's do the same thing. If this is true and that's false, that's going to be false. If this is false and that's false, this is going to be true. If this is true and that's true, that's going to be true. And if this is true, that's true, that's going to be true. Cool. Contingency. Fill in the blanks. P and Q are both true. They're both false. This is false. This is true. Not P would be false, false, true, true. And then not P implies that. So this one is going to be true, true, false, and true. Well, where'd I mess up? Let's see. Oh my goodness. Yeah. T, F, T, F, F, T, F, T, F. The last three were wrong. So this one. Oh, this is false. That's false. That implies false. If this is true, I don't understand how this last one's wrong. How is that false? I don't understand how the last one's false. Well, it's obviously a contingency, but I only got one wrong, so that's going to give me most of the points. I'm moving. Oh, because I got that one wrong. Oh, you saw that? Whatever. Yeah, you saw it. All right, fill in the blanks in the truth table. So let's first do not P. So that's going to be, the not P is false, false, true, true. Not P and Q. So false and true is false. False and false is false. True and true is false. False. Does Q imply P? True. If this one would be true, this one would be false. This one would be, if not true, not true. I think that's also false. And then not P and Q, and. So now these two guys would be and. This would be false. This would be false. This would be false. This one I think is true maybe because they both match up. Final check. Oh, this is really hard to check. What did I mess up? I got everything right except the last two. The last two were the ones that I got wrong. So if this, then this and that, true and, oh, it's just that one that I got wrong. If all of these are false, I think that's a contradiction. Yeah. All right, so P implies P and Q. So I think that's true. I think that's true. I think this is false. And I think this is false. No. P or Q. So P is equivalent to P or Q. So maybe this one should be a T? Yeah, so it's or. Okay. Does this true verify the implication? I think it's no. Because whenever P is true, P and Q. Oh, so that's what we're checking. Okay. Similar question. Let's just do that. This is P and Q. True. Just again, or true, and that's false. And then does this yes, because wherever P is true, Q is true. P or that one is true. Okay. Complete the truth table below. Q implies not Q, which then P and not Q. Okay. So P and not P. So I'm looking at this column and that column would be false. That column would be false. This would be false. This one would be false. Not Q implies, so now if I take this implies that. So if it's false, then it's false. false. If it's true, then it's false. It's false. If it's false, then it's false, and it's false. And if it's false, are these all F? No. So not P and. Let's try these. Maybe these are true. Maybe this one's true. There we go. Because if it's false, then yep. Okay. Hopefully that makes sense. Therefore it does. Everywhere that I see Q, it should be true. 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 Yes. Yep. Everywhere I see Q, it's true. Complete the truth table below to verify the equivalence. Q and P or Q is equal to Q or P and Q. Yes. Because you have the P or Q, and then you have the okay. Complete the table below. Q and P or Q. So these are both true. Q and P or Q. That's false. Q and that's true. And if they're both false, I think that is it false or true? Oh my god, if they both match, then I think this is false. Okay. Now Q or this is true, false, true, false. I may have messed up. Nope, got it. Cool. You're just looking for the or. Is it equivalent? TF, TF? Yes. All right, let's complete this table. Let's see. We got Q and this. So these both have to be true. So that's true, false, false, false. And then P implies Q. So now P and T, F, F, F. Yep, because you're just looking for, they have to match and or. T, F, F, yep, they're just equivalent. Alright, verify the following equivalence using the formula for some logic at the right. So, not P is P. P or Q is equal to Q or P. P and Q is equal to Q and P. If P implies Q, then not P or Q. I think it's this. I'm just looking for the difference. What am I looking for? Which is not equivalent to the equivalence that is false because it's right here. It's either, I think it's one of these. No, is it number 4? The correct answer was B because not P and not Q. So that statement was true. Okay. Similar question. It's equivalent because they equal each other. All right, moving on. Verify the equivalence using formulas. If not P implies Q, they're equivalent. If P is a proposition, I want avocados, and Q is the proposition, I want cucumbers. Rewrite the sentence, I do not want avocados, but I want cucumbers. I want avocados. So how do I do not P? Not P implies Q. Is that going to accept? Let me see if I need to change the capital letters. Not P and Q. Oh, mother flower. What is it? It's not P and Q? Oh, because they're both statements. They don't imply each other. I gotcha. So here, I want peppers and I want cucumbers. Statement, I want cucumbers would be, I want cucumbers is Q and, but I don't want peppers, so that would be not P, right? Yeah, cool. All right, in the conditional proposition, P is a contingency, is not P also a contingency? Is it a contingency? Yes, because at least one entry would be true and at least one entry would be false. Yep. And when you negate a truth table, you get, so yeah. Can a conditional proposition be false if its contrapositive is true? I think they're logically equivalent. I think a contrapositive, yep, and a statement and the contrapositive is also true. So it's like, if it's raining, then I have an umbrella. Well, if it's not raining, then I don't have an umbrella. That kind of cool. And that's a chapter. Awesome. A lot easier than chapter 6, guys, right? A few questions in here that now that I've done, number 30, I could probably go back and get them done much easier. Let's see, question 2. I'm not going to do that one. 5. I'm not going to do that one. 9. That was fine. I think it was just 15 that I messed up on. So let's see. Not Q would be false. Oh, that's P. Not P is false, false, true, true. And then not P implies Q. So false implies true would be true. False implies false would be false. True implies true would be true. And true implies false. So this one true. Mother freaking. Yep. If it's false and false. All right, cool. And that's the chapter. Awesome. Best of luck.